Looking at 2-4, and we are going to add integers today. Okay, what are integers? That's what we need to answer first of all, because I already know you know adding or addition, but what are integers? Yes, John?
Every whole number and its opposite.
Good. It's all the whole numbers and their opposites. What are the whole numbers? What are the whole numbers? Rosa?
Isn't it like 0 to infinity?
Yeah, it's 0, 1, 2, 3. So it's 0 and all the natural numbers. What are the natural numbers? See how we're getting like smaller and smaller groups? Yes?
Is it the counting number?
The counting numbers. You naturally count. We call them natural or counting, but that's what you naturally count with. All right, so we're adding integers. So we're talking about all the whole numbers and their opposites. And that's what we're going to do today. Let's look at example number 1. What do they use to add their integers? What method are they using, or what process are they using to add their integers? Yep, Tristan?
They're using a number line?
Number line. That is one way to work it out. Bless you. One way to work it out is with the number line, and we're going to do it that way, and we'll also find out another way to do it. All right, so example number 1. They're adding -5 and -2. So -5 plus -2. Okay? So we get my number line started. And I'm going to put 0 over here to the far right because I'm going in the negative direction. Okay, I'll go a few out. Go -1.
Do we have to write that number line?
Yes. And again, we want to understand what they're doing. You won't have to do it on your problems, but I do need us to see what we're doing with our number line here when adding integers. Okay. Question, Sophie?
Do there have to be parentheses around the 5?
No, it doesn't have to. I think they wrote it without it, but you'll see it many ways, so that's fine. Okay. When you're adding and or subtracting, you're going to start with the first number here with 0 as your starting point. So from 0, which way should I go to get to the -5? I should go left 5. So I end up right here. Okay, so that was -5. Okay? But I'm going to add to it how many? 2. And what sign with it? Negative. So I have to go which direction? Left again. 2 more. And what number do I end up at?
-7.
-7. So we get our answer here of -7. Okay, so basically what the rule is when you're using the number line and you're adding 2 negatives, a negative number makes you go to the left, a positive number makes you go to the right. So that's pretty basic, right? Straightforward, no problems there. All right, so that's how you do that first example right there. But using the same number line, let's get another problem going here. Let's go with, so this is not an example. Let's go with -3 plus -2. Okay? So what you can do is you can either do it with a different color, or I'm going to do it underneath and do this problem down here. Okay, starting at 0, where do I go? If I have a -3, where do I go? Which direction and how many? Left 3. So I get here, that was 3 to the left. And then from there, where do I go? Again to the left twice, and I end up at -5 right here. Do you guys see that? This is easy, right? That's kind of nice. So I get my -5. Any questions on that with the number line? Okay, yes, sir.
When you're adding them, couldn't you just add normally and then just put the negative sign before it? So
I hope there's a better way.
5 plus 2, and then you get 7, which and -5 plus -2 is -7. Couldn't you just do 5 plus 2?
Yeah, remember what I said at the beginning of this lesson? How many ways am I going to show you how to do it? 2 ways. So we're doing one way, just one way of doing it. I want now people to tell me what are the benefits and what are the negative results of using this method. So just help me out. Speak it through here. Tristan, give me either a benefit or a negative on it.
Negative, there's probably a faster way you can do it.
Okay? This is going to take me a long time. If I have to put all of these on number lines, it takes me a long time. So time is definitely a negative thing. Yes?
And then also, like, there's a good thing for visual learners. If you like to see it spread out and laid out like in a picture, that could be good for those kind of things.
Yeah, some of you, or maybe either you're visual or you don't really get this. This is going to help you to picture it out, and then you can see which way you're going and all that. That's good. Sophie?
Like, this was much better thought out in my head, but you could, like, for, like Marissa said, for visual learners or non-visual learners, maybe it could get too crammed if you just did it on one number line.
Yep, it could get kind of messy, and even if you did it right, you might, if you're messy, you might get the wrong number. You're like, oh wait, that's -6 for -2 plus -5, but it's actually not because it was not done correctly or messy. It was done too messily. Okay, yes, Bella?
If you're adding or subtracting bigger numbers, you would have to write out, like...
Oh man, like what if this were, and I'll show you that you could still do it, but it is harder. What if I had -33 and -20? Oh man, so I'm having to either do by tens, and I could do little divisions there, but then my answer might not be as accurate. So bigger absolute values will ruin this. Oh man. Last one. All right, I think you guys kind of covered it. Yeah, I think you're right. This is good if you want to visualize it, or maybe you're first starting to learn this. Great, use a number line. But it can get messy. The numbers can get really big. And man, this takes a long time. So this is one way, but it's not the best way. So let's look at another way. Turn the page. Let's look at example number 2. So example number 2. And this one gives us 8 plus -4. Oh. 8 plus -4. Okay. So again, I could use the number line, and if I'm kind of visualizing a number line, here's 0. +8 would go 8 this way, and then -4 would go to the left. Where would I end up at? John? +4 would be my answer. There you go. So that's using the number line. This is another way I use. It's called a number mat, or some people call it like an algebra mat. I kind of like this way because it's not as long as the number line, and it kind of helps you picture what's going on with these numbers. Okay, go ahead and draw this mat real quick. It's just a rectangle divided in 2. One side is positive, one side is negative. I think when I taught it in years past, it was like a battlefield. I'm like, oh, that's intense. Why is it a battlefield? Well, I'll try to explain that to you. All right. This is a number mat, and I'm always trying to find what's the total value of this number mat, or this algebra mat. Well, what am I putting on it first? I'm putting 8 positives, right? Isn't this a +8? So I'm going to put 8 positive counters, we call them, or circles. 8 positive counters. You can also do this with, if you have little chips, you can do it. Okay, so would you guys agree that this is now worth +8? This is worth +8, so that's how we get that first number. And then what am I going to add to this mat? I'm going to add what? What do you think based on that number? I'm going to add...
-4.
I'm going to add 4 negatives, right, on the negative side. These counters are equal in strength. That's how they get the battlefield. So you know what happens to this counter and this counter? They cancel each other out, don't they? They're equally strong, so they just have a battle, and they both pass away. Yeah, they both die. All right. These two pass away. These two pass away, and so do these two. They canceled each other out. So what am I left with? 4 positives. Isn't that my answer? Okay, now some of you might be thinking, you know what, Mr. A? That's really nice. I'm glad you taught us a little bit about war. But that still takes us too long. I actually prefer this mat, not necessarily with addition, but what's the next lesson about? Subtraction, because people start messing that one up, okay? When you have 8 minus -4, you're like, what did you just say? 8 minus -4. We'll get to that, but this mat is very nice to describe what's going on. Okay, but regardless, did we get the right answer, whether we use a number line or the algebra mat? Yes, the answer is +4. How many of you could do this in your head, though? Great, good. We're in good company here. That's good. I'm glad. So what we need to do now is we need to come up with the best way, which is using the rule. Okay? So there are two rules for adding integers. Okay? Here are the rules. And some of you already gave it to me, which is good. Adding integers. And we're going to apply this to other numbers in future chapters. Adding integers. First rule. If the two integers have the same sign. Same sign. That's very important. If the two integers have the same sign, and this is where I want you to think about it. Oops. Add the absolute values and keep the sign of both. All right. That's a long way of saying something I will summarize in just a moment. Okay. So if the two integers have the same sign, add the absolute values and keep the sign of both. Okay? So let's get a couple problems here just so you know. All right. Do you have two integers being added here? Are these two integers being added? Up here. 4 plus 8. Yep. What are the signs of, what's the sign of 4? What's the sign of 4? Positive. What's the sign of 8?
No.
Positive. So do they both have the same sign? Same sign. So what I have to do to figure it out, and I'm going to show you, I know this is a long way of thinking of it, but it applies when the numbers are not so easy. And trust me, in a group this size, most of you, oh, Mr. I got it. Some of you, I think I get it. And then even fewer of you, I don't get it at all. I want to cover all of you. I want to strengthen each group to make sure you fully know it. All right. What is the absolute value of 4? Absolute value of 4. 4. What's the absolute value of 8? 8. You add those two absolute values together and you get 12. And then what was the sign of both of these? So you keep it positive. You don't have to write the symbol for positive. I'm doing that so you understand what we're talking about. So all we did was we got the absolute values of these two, and then we added it, got 12, keep the same sign. Okay, that also applies for negatives. Okay, do we have two integers being added? Yes. Do they both have the same sign? Yes. Yes. So what is the absolute value of negative 3? 3. What's the absolute value of negative 8? 8. What is 3 plus 8? 11. What sign did they both have? Negative. So you keep that sign, it's negative 11. Negative 11. Negative 11. Okay, there you go. Negative 11. You guys see how we work that out? There are rules that we follow, and eventually you're like, oh, Mr. I got these rules. Great. You don't have to think about the rules, but you have to understand that there was a rule, and you followed it, and now you just do it second nature. And guys, I'm spending a lot of time on adding integers because when you get into subtracting integers and then adding and subtracting rational numbers, you better keep these rules there because sometimes you're like Max maybe, ugh. But it's the same rule, ugh. It's the same rule. You do the same thing. So I'm prepping you up for the harder stuff. I know this is not hard, but it will get. Trust me. It will get there. Okay. Nice grunts. Thank you, everyone. Okay. Let's look at example. I think it's 2. Yeah, 2B. This one's a little different. It's negative 7 plus 4. Okay. Do we have two integers being added? Yes. Do they have the same sign? No. So does the first rule apply? Nope. So this is what I want you to do. I know I'm not going to make you do this on your own. I want you to do it with me so we understand the many ways why this would get me whatever answer I have. Okay, draw me a number line real quick. And the furthest you're going to go is to -7. So I'll go 0, -1, -2, -3, -4, -5, -6, -7, -8. Okay, I'll go to -8, just for good measure. Does anyone like drawing a number line? No? Yeah, some of you are like, I know. Don't be afraid. I sometimes like drawing a number line, making them evenly spaced. Thankfully, you don't have to do it all the time. That's nice. But it's also nice because it's helpful. Okay, so here's my number line. Here's our problem. Where do we start off at? 0. And we start with a -7. So where do we go from there? We go to the left. How many times? 7 times. We end up right here. Some people draw arrows, which is fine. And then from there, where do I go? It's a +4, so now where do I go? 4 to the 1, 2, 3, 4. That's +4. And where did I end up at? -3. That would have been my answer. Mr. A, can't you just... Yes, you can, but we got to find out the reasons why. Everyone good with the number line? If you're adding on the number line, negatives go to the left, positives go to the right. So we understand that. But it's different when you subtract. We'll get to that later. Yes, ma'am.
So
Go ahead and draw this out when you're as you're waiting. Go ahead.
-7 plus +4.
-7 plus +4. Huh?
Why wouldn't you go, since it was +4, and I know you have to subtract it, like, for that rule, but why wouldn't you go to the legit +4 and you went to the negative?
Oh, so you went 7 and then you go all the way to the 4?
Yeah.
Well, because what this is saying is you start with the -7, which I think you're good with, and then from there you add 4. So you're adding 4 units.
I thought we
to
were
the
at
right.
+4.
Like you just jumped to +4. Yeah, so good. I hope that clarified a little bit. All right, what are you starting with on this algebra mat? How many negatives? 7 of them. So 1, 2, 3, 4, 5, 6, 7. Okay. And then what are you adding? +4. So how many do you put on the positive side? 4 of them. And there's a battle. And there are casualties. And they are even for both sides. How many do I lose on the positive side? 4 of them. How many do I lose on the negative? And what am I left with overall for the value of the algebra mat? Oh, wow, -3. Imagine that.
Negative wins the battle.
Negative wins this battle. Yep, that's exactly right. You know what? Let me give you this. Actually, John, you gave me a good point here. On problems where you're adding 2 numbers, 2 integers, and they have opposite signs, almost every battle, positive or negative wins. It's got to be one or the other. There are some where neither wins. It's a tie. Can you give me an example of a tie? Give me a battle that is a tie. Example. There are many. Elizabeth?
Plus -5.
Okay, so you're saying 5 plus -5, right? And if I do this little mat here, I'd have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The battle rages on, and no one survives. Which means the algebra mat has a value of 0. So is 5 plus -5 0?
Yes.
Oh, guys, thank you so much. Remember properties? We just came up with a property. Any number plus its opposite is always going to give me 0. That's called the additive inverse property. That means this again. Ready? Any number plus its inverse, any number plus its opposite, always going to give me 0. Always. The battle always ends out at a standoff. And we just wait for the other battles to rage on. Okay, question. Go ahead.
One day can we watch NC State?
Yes.
Excuse me.
It's a math song.
I'm trying to translate. What does that mean? Jack.
It's a guy who makes rap videos on
About math. Just look up MC Sandy math.
It's really cringy.
No, he just it actually helps a lot.
All right, so yes, if you like those songs, I'm all for them. You go listen to them. You can even impress your friends by rapping with him, apparently. But whatever the rule is, whatever the memorization tool, you got to be able to know why you're doing what you're doing. Because I grew up math. I love math, and I liked it a lot growing up. But I always wondered to myself, why do we do this? And I want to try to give you the whys, like the reasons why we do it. The algebra math, the number line, they all help me out. Yes, ma'am.
Any number plus its opposite
Oh, nice.
equals
0?
0.
Uh-huh.
What about if you subtracted that?
Good question. So we'll look at that tomorrow, but the answer is going to be this. A number minus its opposite is going to be double the number.
What?
Okay, we'll get to that later. That's later. And that's not a property technically, but it is something we'll look at. Okay, sorry. Second rule here then. If two integers, I'll try this again. If two integers have different signs or opposite signs, subtract the absolute values so this will be lesser from the greater, and I'll explain what that means in just a bit.
Have different, subtract the absolute what?
Have different, oh, I'm so sorry. I'll put it here. Different signs. I apologize. Subtract the absolute values, lesser from the greater, and keep the sign. I'll put it back up in just a bit. Keep the sign of the larger, and I'm going to put here absolute value. Okay? There you go. There you go. That's all. I know that's a lot. That is a lot. That's the rule, and then we're going to make it practical, okay? Because I know that's a lot to write down. But it is good to know what the rule is, and then how does that actually work when I work out my problems. Okay. Does anyone get that?
No, me.
Okay. Can you help me out? Just kind of summarize it. Or you can restate it. That's okay. No, you're okay.
So it's not saying things like
When you have two numbers being added, they're opposite signs. What do?
you have when you subtract the absolute value lesser from the greater and keep the signs of the larger A, B, Z.
There you go. All right. Yes, sir. Callie?
Yeah.
What's A?
Okay, that's all right. Anyone want to summarize? Absolute value. Absolute value. Yes, ma'am. Like, what does this mean?
Like different, if you have two different signs of the numbers, then you subtract the absolute value and you keep the sign of the number that's there.
The larger absolute value.
We're saying the exact same thing.
Right? It's hard to describe that process without saying all of it. That's the thing. It's hard. You got to like put those all in. But hopefully you guys know the process pretty well practically. Okay, let's look at example 3. Example 3 is this for A. Okay, they gave us an equation, x equals -9 plus 6. Okay, how do I know this is an equation, by the way? This is an equation, and I know it because blah. Marissa?
Because it has one operation and a variable.
So you're thinking algebraic expression. I'm saying this is an equation, and this is y. Elizabeth?
It has an equal sign.
It has an equal sign. So can we solve this equation? Yes. You're not simplifying this equation, you're solving it. I want to find what is x. Okay. Here we go. This is what we do. Are we adding these two integers? Yes. Do they have opposite signs? Okay. Find the absolute values. What's the absolute value of 9? Or excuse me, negative 9? 9. What's the absolute value of 6? 6. And then you're going to subtract these two. You're going to do the lesser from the greater. So you're going to do 6 from 9, which is the same thing as 9 minus 6. And what's that? 3. And then which one of these had the greater absolute value? The positive number or the negative number? The negative number. And therefore that is the sign of the sum. Yes, ma'am.
So like I get all that, but if you you just like do it in your head?
No. Gotta show me work. Yes, for now. Soon you'll be able to do this in your head. Yeah, like do that. I hope that's not too burdensome. And before we get to that, I'm missing something.
What?
What is it?
X.
X equals negative 3. Some are taking it harder than I thought. Okay, but anyway, that's what you want to have for your answer. X equals negative 3 because you're solving to give me what the variable equals. And in that case, it's what it equals. Okay, B. B is going to be 8 plus negative 3. 8 plus negative 3. And then they do something to us. Plus 4 equals A. All right, is this an equation? Yes. Why? There's an equal sign. So I know I'm solving. I got to find what the variable equals. That's my whole goal. And really, it's just working out this problem right here. Oh, my.
I know what we should do.
Hold on. Raise your hand. We can work this out many ways. But using what property can I add the two positives first and then add the negative with it? Jensen? Kind of. But what do I have to do to those numbers first before I can associate them? Michael? Not distributive. There has to be addition and multiplication for distributive. Tristan?
Commutative.
Commutative. Are these three integers being added?
No.
Does it matter the order of your addition? No. Can the addends be rearranged? So I'm going to do this. Can I do that?
No.
Am I allowed? Yeah. So it's 8 plus 4. You can do that in your head. How about that? That's 12. Then you have 12 plus negative 3. Close. Hold on. Then what we do here is, do we have two numbers with different signs? Listen, guys, look. Some of you are looking at me and saying, why are we spending so much time on this? I am telling you right now, the 8th graders who were 7th graders last year, they're also thinking to themselves, come on, Mr. A, this is easy. And then I go over the same stuff this year, and they're like, what happened? I don't get what to do. It's the same thing. Drill this into your head, and then when we get you tougher numbers, fractions, decimals, mixed numbers, variables, you're fine with it, but you got to get this drilled in. Got to get it drilled in. Got it. Because then you're going to struggle, and I don't want you to get there. I want you to do well when it comes. Okay, but anyway, what's the absolute value of 12?
12.
12. What's the absolute value of negative 3? 3. Since you can subtract those two, what do you get? 9. And which one had the greater absolute value?
Positive.
The positive number, so it's going to be positive 9.
No, A equals positive 9.
Very good, yes.
Everybody got it.
Equals 9. And you don't have to write the positive if it's a positive number, but you can. It doesn't hurt. I do it for emphasis. Yes, ma'am.
Why can't you just look at the original one
Mm-hmm.
and then do the absolute values and then start subtracting everything?
Very good. So why can't I get these absolute values and start subtracting? Good question. The reason is this. Remember our rules? How many numbers are in both of our rules?
4?
No.
2.
2 for the first rule, 2 for the second rule. Did we have a rule for 3 numbers? Did we have a rule for 3 numbers?
No.
No. I have to either take these two at a time. I could do these two, apply the rule, and then that sum and that two at a time. I can't do it all with three unless they all have the same sign technically. We'll get to that later. But yeah, take two at a time. And that'll help you out. Okay, great question. A equals 9 on here. A equals positive 9. Okay. Yes, sir, Jensen?
Can you just use the battle map?
Is that why?
The battle strategy thing?
You can use the battle, yeah, if you want to use the battle.
For this one, though, right?
Sorry?
Couldn't you use it for this one, though?
Oh, yeah, you can use it for this one. You can use it, I'll do it just real quick. Positive, negative, and I'll make my counters. I have 8 positives, 8 of them, and then I add how many negatives? And then I add how many positives? And so 3 get canceled out. What am I left with? 9 of them. So it works. I like the math. Trust me, for the addition, yeah, it's like, come on, mister, really, the math? The battle's going on? Yeah, the battle rages when it's negative. Negative minus a negative. It's like, what does that mean? It's the same as addition. But we got to see it first as addition. Yes?
For 12 minus 3, why did you put negative 9?
Where's the negative?
Yeah. So the negative is...
No, it's a positive.
Oh, sorry, I don't...
That's okay. Sorry. Oh, okay, I gotcha. Yes?
Can you use the battle strategy if you're like doing negative plus negative?
Oh, yeah. So negative plus negative, let's say negative 3 plus negative 2. So I have 3 negatives, 1, 2, 3, and then I add 2 negatives. So what do I get? Total of negative 5. That would be my answer here. See how that works? I love it. And it's going to be more useful when we're doing subtraction. Okay. All right, last example, then I'll let you guys go. Example number 5. These are a little bit tougher because they throw what into our problems? We just had numbers last time, integers. Now what do they throw into us? What do we call those letters? Variables. Oh, man. Negative 15n plus 22n. Okay. Are these two numbers now being added? Are they two numbers being added? And the answer is yes. In fact, aren't these two like terms?
No.
So can I combine them together if they're like terms? Can I combine them? Yes. That's the cool part of it. You can. You can add them together, make them simpler. Okay, this is the long process. I don't require you to write this down, but then you can do it on your own, the shorter process. Ready? This right here can be rewritten using the distributive property. It would be like this. Let me see if you guys understand what I just did here. You guys get that?
Yes.
Okay? Yes, but what did I just say? I'm going to show you the long process. You could do the short process. I'm just showing you. So what's negative 15 plus 22? Well, they're opposite signs. So I have to find the difference of the absolute value of these two. What's the absolute value of 22? What's the absolute value of 15? Negative 15, excuse me. It's 15. What's 22 minus 15? 7. Is it going to be positive or negative? Positive, because that one had a greater absolute value. So this is what I'm left with. And is that how I write my answer? No. How do I rewrite it? 7n. So all I'm doing here is adding the coefficients of the n's. And then I get
Subtract it.
B. This one is going to be 9x plus negative 18x plus 8x. All right. I live in a world where I don't remember any of the properties, so we're fine with that. Let's see if we can deal with it. All right. How many things are being added here? 3 things are being added. You guys agree? This is being added with this, and that's the third addend. Do you have to add in that order? No. But we're going to assume, you know what, I thought we did, so we're going to do it anyway. All right, what's not, are these like terms, excuse me? Why are they like terms, somebody? Raise your hand. Why are they like terms? I mean, we call them that, we're like, fine, but why? Josie?
Because
They all have x's. We can combine them together into one now. All right, so really the problem is, what is 9 plus negative 18 plus 8, and then you tack on an x after. So what's 9 plus negative 18? Negative 9. These two right here give me negative 9x. What's negative 9x plus 8x? Well, what's negative 9 plus 8? Negative 1. And then the x. So you can write it like this, or you can write it like this. Somebody tell me why I can write it both ways. Wait, that's not the same thing. That has a 1. That doesn't have a 1. That can't be the same. John, why can I write it either way?
In front of every in front of every variable, there is like a number 1 because like anything times 1 is itself.
Okay. So yeah, if I wrote it like this, if I read this as the answer, right, the answer is negative x, and they have negative 1x, mark them wrong, right? No, and vice versa. Okay. I think you guys are good. All right, your homework tonight is so easy.
Yes.
Wait, no. Wait, don't say
19, give us our 18 problem.
No, give us
Today's Thursday. So 19 to 36, and then 38 to 47.
That's not enough.
Oh my. I'm going to turn off Swivl before